Chapter 10 Mechanical Wave and Sound. Learning outcome, properties of wave. A. Define wavelength and wave number. B. Solve problem related to equation progressive wave. C. Discuss and use particle vibrational velocity and wave propagation velocity. D. Discuss the graph of displacement against time and displacement against distance. 10.1a Properties of wave. Wavelength lambda. Lambda is defined as the distance between two consecutive particles which have the same phase in a wave. Figure 10.1 shows a periodic sinusoidal waveform. From the graph, show the position of amplitude and wavelength. Amplitude defined as the maximum displacement from equilibrium position to the crest or trough of the wave motion. Wavelength defined as the distance between two consecutive points which have the same phase in a wave. Particle B is in phase with particle C. Particle P is in phase with particle Q. Particle S is in phase with particle T. The SI unit of wavelength is meter. Period defined as the time taken for a particle in the wave to complete one cycle. Period of the wave equals to period of the particle on the wave. The SI unit is second. Formula period equals to 1 over frequency. Wave number. Wave number is defined as the number of cycles of a wave in unit length. Formula for wave number equals to 2 pi over lambda, where lambda is a wavelength. The SI unit of wave number is meter to the power of -1. Frequency. Frequency is defined as the number of cycle wavelength produced in 1 second. The SI unit of frequency is hertz or second to the power of -1. Amplitude. Amplitude is defined as the maximum displacement from the equilibrium position to the crest or trough of the wave motion. The SI unit for amplitude is meter. Wave speed. Wave speed is defined as the distance traveled by a wave profile per unit time. Figure 10.2 shows a progressive wave profile moving to the right. According to the figure, wave profile represented by the lambda. Speed. Wave speed equals to distance over time, where distance represented by the wavelength, time represented by the period, and from the formula period equals to 1 over frequency, we substitute the formula of the period into the formula of wave speed. Therefore, we find that wave speed will be equals to frequency times wavelength. V equals to F lambda. The SI unit of wave speed is meter second to the power of -1. Mechanical wave. Mechanical wave is defined as a disturbance that travels through particles of the medium to transfer the energy. The particles oscillate around their equilibrium position but do not travel. All mechanical waves require: first, some source of disturbance. Second, a medium that can be disturbed. And third, a mechanism to transfer the disturbance from one point to the next point along the medium. Example of the mechanical wave: water wave, sound wave, wave on a string or rope, wave in a spring, and seismic wave or earthquake wave. Figure show hand of pitcher and hand of catcher, where hand of pitcher act as some source of disturbance. Then the energy transfer from one point to another point along the rope. From this animation shows that the energy transfer from hand of pitcher to the hand of catcher, where energy transfer along the rope. The rope acts as a mechanism to transfer the disturbance from one point to the next point. Example of sound wave. Playing a drum, as shown in the figure, is an example of sound wave. Next, we move to another example. Boy A is talking to boy B. So, boy A produces sound wave and transmit energy to boy B. Next, we move to another example of mechanical wave, which is a water wave. This is an example of a water wave. Wave and energy. Wave is defined as the propagation of a disturbance that carries the energy and momentum away from the source of disturbance. Equation of displacement for sinusoidal progressive wave. This is the graph of displacement against distance from origin. From the graph, the wave profile propagates to the right, thus the other particle will vibrate. The equation of displacement for particle at x equals to 0 is given by the equation y equals to a sine omega t, where y represents displacement, a represent amplitude, omega represent angular frequency, and t represent time. This is the graph of displacement against distance. From this graph, the particle at point O and P. The vibration of particle at P lag behind the vibration of particle at O by a phase difference of phi radian. Thus, the phase of particle at P is equals to omega t minus phi. Therefore, the equation of displacement for particles vibration at P is y equals to a sines omega t minus phi. Three particles in the wave profile that propagate to the right as shown in the figure below, which is point O, point P, and point Q. From this graph, it shows that delta phi or phase difference equals to 2 pi and distance represented by x equals to wavelength. When delta phi or phase difference increase, hence the distance between two particles x also increase. Therefore, we got the relationship phase difference or delta phi is directly proportional to the distance from the origin x. From this relationship, we got that phi directly proportional to x, where phi over 2 pi equals to x over lambda. From this equation, we rearrange the equation. Phi will be equals to 2 pi over lambda times x. Then, we know wave number or k will be equals to 2 pi over lambda. We substitute formula of wave number into the formula of phi. Then we got that phi equals to kx. General equation of displacement for sinusoidal progressive wave. If the wave propagates to the right, the equation of displacement will become y in bracket x t will be equals to a sines in bracket omega t minus kx. If the wave propagates to the left, the equation of displacement will become y xt equals to a sines omega t plus kx, where from this equation, y represents displacement of the particle as a function of x and t. A represent amplitude of the wave, omega represent angular frequency, k represent wave number, x represent distance from the origin, and t represent time. Phase angle phi indicates the position of the particle at distance x equals to 0 in the wave when the time t equals to 0. If the displacement y is 0 at x equals to 0, t equals to 0 as in figure below. This is the graph of y again distance when x equals to 0 and t equals to 0. Examples of the displacement for sinusoidal progressive wave. Okay, this is the graph of displacement against distance. From this graph, it shows that the displacement of all the particles in the wave at any particular time. Equation of a particle's velocity in wave. By differentiate the displacement equation of the wave, y equals to a sines in bracket omega t plus minus kx. Formula of particle velocity equals to dy over dt. Then we substitute the formula of displacement into the formula of particle velocity. We differentiate the equation. We got that particle velocity will be equals to a omega cos in bracket omega t plus minus kx, where v right now represent velocity of the particle in the wave. The velocity of the particles varies with time, but the wave velocity is constant. Thus, particle velocity will be equals to wave velocity. Okay, now we take a look at the difference between the particle velocity and wave speed. take a look at the table given. From the table given, particle velocity defined as a speed of a particle vibrate with simple harmonic motion around its equilibrium position. However, wave speed is a speed of the energy transfer or wave profile from a wave source to another place. Formula particle velocity V equals to omega square root A squared minus Y squared. However, formula for wave speed V equals to F lambda. Displacement graph of the wave. From the general equation of the displacement for a sinusoidal wave, y will be equals to a sine in bracket omega t plus minus kx, where the y is the displacement, varies with time t and distance x. Graph of displacement against distance. The graph shows the displacement of all the particles in the wave at any particular time. For example, we consider the equation of the wave as a y equals to a sine omega t minus kx. At t equals to 0, we find that the equation will become y equals to negative a sine kx. Thus, the graph of displacement y against distance x given by the curve C. For the curve D, represent the graph of displacement at time equals to t1. The explanation about the graph, curve C, the displacement of all particles at t equals to 0 second. Curve D, the displacement of all particles at t equals to t1 after the wave propagates by distance x1. Okay, the equation of the wave. From the equation of displacement, y equals to a sine omega t minus kx. At time equals to 0, the formula will become y equals to negative a sine kx. That's why our graph before represent that graph for curve C is a graph of in the function of negative sign. Graph of displacement y against time. We already learned about this topic before in chapter simple harmonic motion. We take a look at the graph. This graph of displacement y against time. If we look at this graph in the shape of sine function. So the equation for displacement y will be equals to a sine omega t minus kx. The particle at x equals to 0, the equation of the particle is given by y equals to a sine omega t minus kx. You substitute with the value 0. After that, you got the final equation for displacement. Y will be equals to a sine omega t. Next, when the particle at x equals to 0.25 lambda, what will happen to the shape of the graph? Now we take a look at the equation of the particle given by the y equals to a sine omega t minus kx. Now, the value of x you substitute with the value 0.25 lambda. Then, that we have learned before, wave number equals to 2 pi over lambda. We substitute this formula into the formula of displacement. Then we got the equation will be displacement will become y equals to a sine in bracket omega t minus pi over 2. From this equation, we generate the graph. We identify that our shape of the graph is like this. Graph of y against time when x equals to 0.25 lambda. Okay class, now let's test your knowledge about today's lesson. Take a look at the question given. Read the question carefully. The question given for you the equation of the displacement where x and y in centimeter and t time is given in second. The question asks you to find the value of amplitude, wavelength, frequency and speed. Try to solve it and then submit your solution at the Google Classroom. Okay, that's all for today. Thank you for watching. Bye.